Hi everyone, the topic for this video is hypothesis testing in statistics. Hypothesis testing in statistics. Okay, so first let's talk about how do we use hypothesis testing in our real life, right? Okay. So using hypothesis testing in real life. Okay. In real life, when we do hypothesis testing in statistics to answer the questions we propose, in fact, what we're doing is first linking the two hypotheses with two populations, right? Okay, with population, say 1 and population 2. And by using our data, we're gonna make the decision by putting the results in either population 1 or population 2. Okay, let me do an example and to tell you what it means. Okay, let me finish this by saying that the experiment usually is to decide, or when I say experiment, we can say research or data analysis, is to decide which population you are in, or the data, the samples give you the population, right? Which population is in. Let me go back to our example in the previous example, right? So if we are looking at whether NAPS can help you reduce your homework time, right? If that's the question, then what are the two populations that we're looking at? The null hypothesis, remember, is the no change or the boring or the status quo. Hypothesis would be population of people who NAPS don't help, right? So if you see that NAPS don't help reducing homework, then you are kind of talking about a population of people that NAPS don't help reduce homework time. Where the alternative hypothesis is associated with population of people NAPS help reduce homework. And then when you do your data analysis or statistics analysis by picking out a set of data points or a sample of yourself, yourself's homework time with NAPS and without NAPS, basically what you're doing is you're putting yourself into one of these two populations. To say, what we're doing is put yourself in a population, okay? So that's basically what we're doing. So we can imagine that the two hypotheses are associated with two types of populations, and then use your data to put yourself or the object you're studying into one of these two populations. And that's what we're doing with hypothesis testing. Okay, let me go ahead and give you another example. Example, let's say we're looking at the national reading speed. Okay, the national reading speed is what we're interested in, and the population mean is 300 words per minute. Let me just keep it simple, say 300, and then the this is mu, and then the population standard deviation is 40, which we know as sigma. And then Mike is someone that does these tutoring classes and tells you that his class can help you increase your reading speed. So the question we're interested in, Mike's class increase reading speed. Reading speed, that's the question we are asking, right? Whether this class is helpful. And let's write out the null hypothesis. Okay. Let's first write the null hypothesis. So again, the null hypothesis would say that Mike's class doesn't help you increase your reading speed, right? So in this case, the population we're looking at is the population with the mean 300, right? So under the null hypothesis, mu should equals to 300. Okay. Now, what I want to do is I want to show you graphically with the distribution to show you the topic we discussed in our previous video, which is testing our null hypothesis. Okay. So let's assume we have normal sampling distribution. And again, the reason we want to make this assumption is that then we can use our z-table, z-scores, and things just be very, very simple and easier to do, right? So let's assume that we have a normal sampling distribution. And let's do like this. Okay? And the way we do this is we assume that this normal distribution represents that your null is true. So this is the normal distribution under the null. Okay, so let me use a red pen. So this distribution here assumes that this is normal under the null, which means that this distribution assumes that the null hypothesis is true, right? So this is true. So this assumes that your null is true. Okay. So what it means? It means is that we want to use our data to show whether this is true or not, right? And then what's important is under the null hypothesis, if the null hypothesis is true, then your mean is 300, right? Right? If the null is true, then your mean is 300. Okay. And then to show if the class is helping you to improve your reading speed, what you want to do is you want to reject this. You want to say this is not correct. Okay. Let me do a line here first, okay? The line here, and I'll explain to you what this means. Okay, so next we want to talk about the concept of critical value. Okay, so what critical value here represents is to give yourself a cutoff point to say that if we pass this critical point, this class is helpful. So the no is not true. So the critical point is where to set your cutoff point. To set your cutoff point. And let's say, in this case, that 360 is the critical value. Okay, so 360 is the critical value what it means is that, okay, if after mice class, your reading speed increased to 360 words per minute, then this class is helpful. So 360 is here. And this is our critical value. Okay, so remember that what does it mean for mice class to be helpful is your reading speed increased, right? So if your reading speed stays the same or even slower, then this class is not helpful. So anything above 360, where is the critical value or the cutoff point is set, is the rejection region, which means that you're going to reject the no and say the alternative is true, and then here the alternative is that mice class is helpful. Okay, so this is our rejection region. Okay, and then anything below 360, anything lower than 360, like this, it's the fail to reject region. Okay, fail to reject region, right? So it all depends on the critical value, whether it passed 360, which means the higher, or lower than 360. Okay. Okay, good. And let me just say that the alternative, right, in this case is mu is greater than 300. And then here, I'm going to change this back to less than or equals to 300. Okay, next. Next, let's talk about the concept of critical region and significance level. Critical region and significance level. Okay. Critical region and significance level, what it means is that, let me do the normal distribution again. Here. Okay. Okay, so what I'm going to do is I'm going to denote the mean to be mu h naught, right? So is the mu under the null hypothesis, or assume the null hypothesis is true. And then once you have this, the next step is that you want to pick your critical value, right? You want to pick your cutoff point. In this case, instead of that one, so that one, the mic's reading speed 1 looks at one-sided, but let's imagine this to be two-sided. So critical value here, and critical value here. Which means that if your value is very different from the population mean under the null, like if it's really small, it's smaller than the critical value, or if it's larger than the critical value, we are going to reject. To say that since it's so different than the mean under the null, then it's not likely to be this value here. So we're going to reject the null. Okay? And then these two areas are what we call the rejection region. Okay? And let's see what we do in our data analysis or statistics, right? In our data analysis or data statistics, you will have a sample point. Okay, you have your sample point. And if your sample point, say, it's here, right? If your sample point is here, since it's close to the mean under the node, if your sample point shows you this, then you're gonna fail to reject the node. But if your sample point is outside the critical value, say here, SP2, SP1, then in this case, you're going to reject your node. Okay, so you have your distribution under the null hypothesis true, and you have your critical values. Then with your sample point, you're going to decide whether the null is true or the alternative is true. Okay, and let's talk about significance level. Okay, so significance level. So for significance level is denoted with alpha. So when you see alpha, you know it's significance level. So what's the definition of significance level? So the definition is the probability rejecting the null when the null is true. Okay, so you reject the null when the null is true, and this is a mistake, right? So this is a mistake. But before you do your testing, you're going to decide your alpha, which means that what is the level of mistake, or what is the probability of mistake that you allow yourself to make with this testing. And that's our significance level. And if you look at this graph here, this distribution here, under the null hypothesis, so assuming the null hypothesis is true, which is the null hypothesis is true, what is the probability that will reject, right? So the probability will reject is this region, this rejection region, plus this rejection region. So in fact, our alpha equals to the sum of the two rejection regions, okay? So it's the sum of the two rejection regions, this shaded area plus this shaded area. And that's the one-sided test. Let me quickly give you alpha when we do the one-sided one-tail test. Okay. Okay, so that's the one. Oh, what I wrote here was the two-sided. So now we're looking at the one-sided test. Okay, so for one-sided test, it's possible that if the value is smaller, you reject. So since we're still saying that the mu H naught is here. So if the value is small, right, so it's lower than critical value, you're going to reject. Then this is your alpha. If when the value is higher or bigger, larger than the critical value, you're going to reject. Then you're looking at this case. Okay. The mu H naught is here, your critical value is here, then this is your alpha. Okay. So it depends what type of test you are looking at and whether you're doing the smaller scenario or the larger scenario. You're looking at the alpha to be this region or this region here. Okay. And what are the common alpha that we use before we do the testing? Some of the common alphas are, so common ones, alpha equals to 0.05, so 5%, alpha equals to 0.1, 10%, or alpha equals to 0.01 or 1%. It depends on the level of mistake or the probability of mistake you allow yourself to make with this test. Then you decide your alpha. Okay, cool. And let me finish this video with a final note here. Okay. A note. If you have a lower significance level, right? So if your alpha is small, then this will be harder to reject your null hypothesis, right? Because you're not allowing yourself to make that much of mistake in rejecting the null. And in this case, you're being more careful, I would say. Okay, so you're being more careful, so you're less likely to reject your null. So less likely to reject null. Okay, okay, good. And so, which means that if we use alpha, so alpha small, then we're gonna say less likely to reject your null. Okay. So this concludes our video, and I'll see you in next video. Thank you for watching.